Okay, this is type 1 molarity problems, and it consists of calculating molarity from grams or moles given in the question. Okay, so for this type of questions, for type 1, we're basically using moles of solute over liters of solution for what we're looking for here in the first process of the dimensional analysis. Okay. So the question is asking, what is the molarity of a solution by adding 7.85 grams of methanol to a flask, then adding enough water to bring the total volume to 153 milliliters? The molar mass of methanol is 32.04 grams per mole. The density of methanol is 0.792 grams per milliliter. Okay. So it's a bunch of information in here for sure. But basically, what they're saying is that you have a container, and within that container, you have 7.85 grams of methanol. And since methanol is going to be mixed with water, then that's called the solute. So you have 7.85 grams of methanol, and then you add water into it to create a solution. And that brings the total volume, meaning the total amount of space that is being occupied inside the container of that solution, to 153 milliliters. Okay. And what they're asking you is to find the molarity, or meaning find the concentration of this solution. Okay. So basically, you're going to use the same formula here in the beginning. You can identify what your solute is. In this particular example, would be methanol. Okay, so I'm going to have some type of number in here at the end, and I'm looking for moles of methanol. Okay, over liters of solution. So you always box what they're asking you to find. And that's basically what I'm doing in here in this step. Box what you're looking for, what you're looking for that you're trying to find. Okay. So this information needs to be shown somewhere here in the top of the dimensional analysis. And then this information needs to be shown somewhere here in the bottom. If not, then I have done something wrong. Okay. So we're going to write 1 over 153 milliliters. The reason that you write the 1 is because this and this is not a conversion factor. Okay. So, and then the other reason of why you're writing milliliters in the bottom, it's because you want to end up having liters in the bottom, somewhere here in the bottom. So if we were to write milliliters, let's say here in the top, then that means that my units would have to match with the units diagonal to it. So it would be milliliters, milliliters, and then liters. And then that wouldn't make any sense, because we're not looking for liters to be in the top. We're looking for liters to be somewhere in the bottom. Okay. So this is our starting point. Okay. And I got the 153 milliliters from here. Okay. So now I have to be able to match my units diagonally, milliliters and milliliters. So I know that there are 1,000 milliliters for every 1 liter. This is a conversion factor that you just have to remember. Is also in the stoichiometry path uh, that you can use. So 1,000 milliliters for every 1 liter. And guess what? I have found so far one of the units that I was looking for, liters. So I'm good with the bottom part, okay? So now this is where it gets interesting. Now you don't match liters and liters here, okay? You don't do that. Why? Because we have already matched it to what we were looking for over here. Okay, that's why We're not going to be writing over here liters. Now, I'm going to use some of the information that was provided in the problem so that way I can go from grams to moles. Why do I have to write grams here in the top and not in the bottom? The answer to that question is because because you're going from grams to mole. So notice that here I have 7.85 grams of methanol based on the information given. Okay, so that means I have to match it diagonally. Okay, so grams of methanol, and then for grams of methanol, and then 1 mole in the top. Okay, and it tells you right there that the molar mass. So basically, this right here means molar mass. Okay, it's also called counting by weight. Okay, molar mass allows you to count by weight. All right, so grams per mole, grams per mole. So this was the given here, 7.85 grams of methanol. Okay, I have to match my units, grams of methanol. Okay, the 32.04, I'm getting it from the information given here in the problem. Okay, uh, most of the time you can get it from the periodic table, but on this particular example, they're giving it to you in the problem. Okay, and then over 1 mole of methanol. Okay, and guess what? I have found what I'm looking for: moles of methanol, moles of methanol. And then from here, all I have to do is do the math, and my answer is going to come out to be 1.60 moles of methanol per liter, which all this information is equivalent to saying 1.60 molar, or 1.60 molarity is the molarity of this whole concentration here.